Hey everyone, today we're going to talk about the life story of every symbol object in programming. Seriously, from the moment it's born to its final farewell, there are these two incredibly powerful concepts that manage its entire journey. So let's dive in and see how it all works.
This is really the fundamental question, right? Think about it for a second. When you open a file, or when a new character spawns in the game, or when you connect to a database, something has to manage its creation. And then, just as importantly, its cleanup. So how does that happen? Reliably, every single time, without a programmer having to sweat the details.
Well, just like pretty much anything in the real world, digital objects have a beginning, a middle, and an end. They have a life cycle. And managing this cycle, doing it efficiently and safely, is honestly one of the most critical jobs in all of software development.
And the stars of this whole show are the constructor and the destructor. You can think of them as the bookends to an object's entire life. The constructor is like the welcome party, getting everything set up. And the destructor, well, that's the cleanup crew that makes sure everything's put away neatly. Let's break them down.
Okay, first up, the birth of an object. This is where the constructor comes in, and its whole purpose is to make sure every object gets a proper, valid start in life.
Now, the key word here, the most important word, is automatically. You, as the programmer, you don't have to remember to call it. The very moment you say, hey, I need a new object, the constructor just runs. It does all the essential setup work for you, like magic.
So what is all this setup work? Well, it's absolutely crucial stuff. The constructor is responsible for initializing important variables. Maybe it's grabbing a chunk of memory it needs, or it's just setting some sensible default values. The whole goal is to guarantee that the object is stable and ready to be used from the very first second it exists. No weird surprises.
So how do you spot one of these in the wild? It's super easy. A constructor method will always have the exact same name as its class. So if your class is called student, the constructor is also called student. No exceptions. That's the rule.
You can think of the class like a factory blueprint. When you write this line of code, you're telling the factory, hey, I need a new student object, and here's the raw material, the name John. The constructor is the machinery inside that factory that takes that raw material and assembles a perfectly formed, ready-to-use object.
Okay, so that's the beginning of the story. Now let's jump to the other end of the life cycle. After an object has done its job, it's time to say goodbye. And this is where the destructor takes over, to make sure it's a clean, tidy departure.
And yep, you guessed it, just like the constructor, the destructor is also automatic. When the program figures out an object isn't needed anymore, usually when it goes out of scope, which just means you've left the part of the code where it was being used, the destructor gets called to perform the final cleanup.
And its job is every bit as important as the constructor's. It's responsible for releasing all the resources the object was holding on to. This is what prevents nasty things like memory leaks, and makes sure files get closed properly and database connections aren't just left hanging open. It is absolutely essential for a stable program.
Now, a quick heads up, not all programming languages handle this in exactly the same way. In a language like C++, you have these true automatic destructors that handle everything. But in languages like Java or C#, there's a system called a garbage collector that automatically handles memory, but you still have to use some specific patterns to make sure other resources, like files or network connections, are released correctly. So same principle, just a slightly different method. Okay, this all might seem a little abstract, so let's look at some concrete, real-world examples where this setup and cleanup dance happens all the time.
You can really see the symmetry here. When you create a file object, its constructor literally opens the file on your hard drive. When that object is destroyed, its destructor closes it. Simple. For a database object, the constructor connects to the server, the destructor disconnects. For a character in a game, the constructor sets its starting health and puts it on the map. The destructor removes it from the game world when it's defeated. It's this perfect, symmetrical partnership.
So let's actually watch this whole automatic process unfold. Let's say a programmer just declares a file object in their code. Just this one simple line. That single action is about to set off a whole chain reaction.
The moment, the very instant that line is executed, the file constructor runs, all by itself. The programmer didn't call it, they didn't do anything extra. The system just knows a new file object was just born, so its constructor has to run.
All right, so the program keeps running, it uses the file, does its work, and then eventually, the program moves past the block of code where that file object was needed. It's about to go out of scope, which basically means the program's done with it.
And poof, the destructor runs. Again, completely automatically. The program might print file closed, and now we have an absolute guarantee that the resource was cleaned up properly. The programmer didn't have to remember to do a thing. It just worked.
So why? Why do we have this whole system? Why is it so fundamental to modern programming? Let's talk about why this matters so much.
I want you to imagine, for a second, a world without constructors and destructors. It would be chaos. You'd have to manually set up every single variable yourself. Then, and this is the really dangerous part, you'd have to remember to manually clean up every single thing later on. It's an absolute recipe for disaster, just full of bugs, memory leaks, and massive headaches.
But with them, everything changes. You get guaranteed setup and guaranteed cleanup. This amazing idea basically ties the lifetime of a resource, like an open file, directly to the lifetime of the object that's managing it. When the object's life is over, the resource is automatically let go. No exceptions. No, oops, I forgot.
So look, if you remember only one thing from all this, make it this. Constructors and destructors are your safety nets. The constructor guarantees a safe beginning, and the destructor guarantees a safe end.
Together, they form this really elegant, really powerful system that manages the entire life story of an object. It makes sure it's created properly, used effectively, and disposed of cleanly, every single time.
And that kind of leaves us with a final thought, doesn't it? This whole idea of a managed life cycle is so clearly borrowed from how things actually work in the real world. So it makes you wonder, what other powerful real-world principles are hiding in plain sight inside our code, just making our software that much more robust and reliable?